Welcome. In this video, I'll walk you through how Zscaler Zero Trust Device Segmentation uses VRRP for high availability and seamless failover. We'll see how the active standby gateway pair ensures continuous traffic flow even in the event of a failure. So let's get started. To ensure that mission-critical systems stay resilient and highly available, Zscaler device segmentation leverages VRRP for seamless failover and robust reliability. Up until release 7.7, the WAN link was used for HA communication, including VRRP heartbeats and failover signals. While effective, it means that any WAN instability could potentially impact HA performance. Starting with release 7.8, we introduced a dedicated HL link. This was a significant enhancement. VRRP traffic is now isolated from the WAN, ensuring that failover decisions are faster, more reliable, and not impacted by external connectivity issues. The dedicated HL link also supports SAID synchronization between gateways and operates within a secure internal network, minimizing the attack surface and improving both performance and security. So let's walk through the dedicated HA configuration for VRRP. We have our two endpoints, Linux A and Linux B, connected to the LAN side of the pair of device segmentation gateways forming the VRRP cluster. We have a site named port 50 with two gateways. Currently, as you could see, AGN1 gateway is active while the other gateway is standby. Then we added a dedicated HA connection using Ethernet 3 on both gateways specifically for the HA traffic. This interface handles VRRP heartbeat, failover signals, and session sync. And finally, VRRP is enabled for the site. You can configure also the advertisement interval and priority from here, which controls failover responsiveness. This setup ensures faster and more reliable failovers and isolates HA operation from WAN, aligning with security and performance best practices. Pod 50 AGN1 is the master with higher priority, while the other gateway with a lower priority is the backup. As you could see that the master owns the WIP and handles traffic forwarding. And here is our dedicated HA interface on both gateways, which is up and healthy. These interfaces are exclusively used for VRRP heartbeat state synchronization, and it's completely isolated from data traffic. So you see the logical setup, VRRP state, WIP ownership, and healthy HA link status. So in the demo, I'll have the endpoint generate the outbound traffic for internet. The packet capture shows that the ICMP echo request from the endpoint flows through our master gateway. You could see that AGN1 is the master. The other gateway, as we have seen with a lower priority, is the backup. And then we'll simulate a failure by bringing the HA link down on the master, which will transition the master to be at VRRP fault, and the backup takes over master. And now the traffic sent by the endpoint is taken over and served by the new master. Then finally, to check the session sync between the gateways in the VRRP cluster, we'll use the contract Linux utility, which is used to view and manage the connection tracking table for the NetFilter framework. It's also used by IP tables and NF tables. The contract table IPv4 command gives the list of the existing IPv4 connections, whereas the contract sync cache external shows the synced connection entries. So here's our Zscaler ZTS management portal. Here is the site, and you can see that we have our VRRP configured here. These are the interfaces, my two HA interfaces on the gateways. The site has two segmentation gateways inactive and standby. All the VMs here are running in ESXi. These are my two gateways, and here is the endpoint on the LAN side of the cluster. You can see that it is air-gapped with an IP of /32. Quickly verify the VRRP status on the two gateways. You could see that AGN1 is a master with priority 254, whereas the other gateway is the backup. And if I quickly verify the interface on the two gateways, you could see that my master has the VIP address that it will be using to carry the data traffic, whereas on the standby, that interface has no IP. So to check the details on the VRRP, you could see that we have our group 237, 1090.51, as we saw the VIP, which is configured on Ethernet 050, 192.0.24 is the address on the VRRP on the dedicated HA connection between the two gateways. We have our advertisement interval configured, and Ethernet 0 and 1 are the LAN WAN interfaces that we are tracking. So everything looks good here. And let's quickly run the debug on on both gateways, and then we'll start traffic from our endpoint. So this is the endpoint, and I'll run traffic. I'm expecting the master to be serving this traffic, which is exactly what we are seeing now. And while the endpoint is still running the ping, let me stop the debug and quickly run the session sync. And on the master, here is the contract IPv4. I'm filtering for ICMP. As you could see that there is a ICMP session, and let's verify the sync on the standby as well. And you could see that we have the ICMP session synced on both gateways. So this is all I wanted to show. To learn more about the ZDTS capabilities and integrations, check out the rest of the videos in the series or head over to the Zscaler website for more details. Thanks for watching. See you in the next one.